Welcome to AmeenAcademy.com. In physics, let us discuss about circular motion. What is circular motion? Look at this figure. This Ferrari wheel is rotating with fixed center. Is this motion of this outer wheel is a circular motion. Circular motion is described as a movement of an object while rotating along a circular path. Circular motion can be either uniform or non-uniform. During uniform circular motion, the angular rate of rotation and speed will be constant. That means for a particular time, this angular rotation is constant everywhere. That means for each interval of time, the rotation is constant. While during non-uniform motion, the rate of rotation keeps changing. Some of the most common examples of circular motion include man-made satellite that revolves around the earth, the rotation of ceiling fan, a moving car's wheel, the blade in a windmill, and gears in gas turbine, cycle wheel. Lot of examples for the circular motion in our daily life you can see. Wherever you look, there are vehicles running in the road. The wheel of the car rotates. That means everywhere we are simply seeing rotational motion. Now not circular motion means the wheel rotates about the axis. Types of circular motion. Here, look at this figure. This at center, this radius r around the circle, the ball or some weight is rotating like. The circular motion can be of two types: uniform or non-uniform circular motion. The angular rate of rotation and speed are constant in uniform circular motion. Here, each and every time displacement, this angle theta is continuously increasing like. That means what? Here each seconds of time changes, the theta changes is a constant. The angular rate of rotation and speed are constant in uniform circular motion, whereas the rate of motion changes in non-uniform motion. The velocity vector changes direction at every point on the curve during circular motion. Here this is the angular speed or angular velocity. Then here the tangentially the vector that is called v is a velocity vector. This is a angular motion. v is a linear motion. Angular variables. So we will define some angular variables in this topics. First, angular displacement. It is defined as the angle turned by a rotational particle per unit time. It is represented by delta theta and measured in radians. In the figure, angular displacement is measured between the position vectors r and r dash vector. Look at here, this is a center point. Here this is a r vector and it moves to this position r dash vector. So it displays delta theta in radians. So this is the r vector and r dash vector. Then look at here, at each point the perpendicular to this vector is a tangential velocity. Here also v dash vector is v vector. Now we will discuss about angular velocity. It is defined as the rate of change in angular displacement of particle in a circular motion. It is denoted by omega, that is limit delta theta tends to 0, d theta by theta becomes d theta by dt. Here change in theta with respect to change in time is an angular velocity. Angular velocity is measured in radian per second apart from angular velocity and angular speed, a particle in circular motion also possesses a linear velocity and corresponding linear speed. Here, this is a linear velocity, and without considering the direction, it's a linear speed. So, wherever angular motion, there is a angular speed as well as angular velocities happen. Now, angular velocity is measured in radian per second. We know that. Apart from angular velocity and angular speed, a particle is circular motion also possesses linear velocity and corresponding linear speed. Therefore, velocity is ds by dt, that is linear velocity vector is ds by dt, which means change in distance with respect to change in time, where s is the displacement of the particle. Relation between linear velocity and angular speed, omega. Here in vector form, here v, linear velocity vector is equal to angular velocity vector into cross product of radius vector. So v vector is omega vector cross product r vector, where r vector is a position vector. Vector is the position vector, where r vector is the position vector of the particle measured with respect to center of the circle, or v equal to r omega. The acceleration of a particle in circular motion has two components. Tangential acceleration at, this is the component of acceleration in the direction of the velocity of the particle. A equal to dv by dt. Here a equal v square. Here angular velocity is v square and r omega square. Angular acceleration, it is defined as the rate of change of angular velocity of the rotating particle. It is measured in radian per second. Angular alpha equal to angular acceleration is d omega by dt, which is equal to d theta by dt. Circular motion can be uniform and non-uniform depending on the nature of the acceleration of the particle. The motion is called uniform circular motion when the particle is moving along a circular path possessing a constant speed. So, during a circular motion, the velocity vector changes its direction at each point on the circle. That means in every while motion in circle, that each point the velocity vector changes its direction. Therefore, we know that from centripetal force, F centripetal is mv squared by r. Look at this formula, F centripetal is mv squared by r, where m is the mass of the particle, Fc is the centripetal force directed towards the center of the circular path. In this case is always the centripetal force is towards the center. That is why a particle rotating around circular path, here this it is pulled, try to pull towards the center. Then that means that is why this circular path is continuing to balance this centripetal force. An example of centripetal force include gravitational force, the tension in string and friction, etc. So far we have done about circular motion in detail. In further videos we will discuss about further in circular motion. We have done. Please subscribe our YouTube channel.